Now I would like to work through a small coding project in order to exemplify some of the vector functions that we've been talking about, as well as to introduce you to a few new functions. This is consistent with what I said at the beginning of the course, that we would be learning language elements, then practicing with those elements, then learning elements, then practicing. It's a back and forth in order to learn this language. So let's take a look at the project and what our challenge is. The statistics class data contains the names of students in a statistics class along with their score on the final exams out of 100. Note, a couple students did not show up for the exam. Our challenge is to create two new vectors to contain whether or not the score is in the interquartile range and the grade, using the following letter assignment scale. Okay, you get the idea? We have this statistics data. In fact, let's go ahead and read in that line of data, and so that we can take a look at it. I'm going to do that again. I'm going to clear the environment. There's no need to start with a mess. Let me clear the console too. Let's go ahead and read in the data and look at it. So here's what we have. We have the last and first name. We have scores of the students, and you can see that some students did not get a score. They did not go to the exam. So those are represented in our data as NA, which is the code that R uses for not available or missing. So our challenge with this is to add two new columns, two new variables. The first is going to be whether or not the student is in the interquartile range. The second is their grade, and here's the grading scale. All right, the first thing I'm going to do is clean up the data a little bit by eliminating rows with missing data. Now, I'm going to do this a brute force method because there's some learning to be had if I go through this brute force blue collar method. And then we'll look at a more elegant way to do it that will help us learn a new function. So look at line 193. I'm going to create a logical vector, and that logical vector, let's see what it says. So we have a function here, is.na. That is asking, is this data missing? And then we're going to look at the score variable. So we're in the student data frame. We're looking at score, and we're asking, is it missing? If it's missing, it will give a true. But what I actually want is just the opposite of that. That is, I want a true if it's not missing. So I'm using the exclamation point, which you'll recall is the operator for saying not. So is it missing? If it says true, it's missing. I'm going to make that a false. So therefore, what I end up with are true values where there is data and false values where there's no data. Now, how can that help me? Well, look at this line. I'm going to create a variable called last name. I'm going to take the student's last name, and I am going to use the subset or extraction operator, the square brackets, and I'm going to put in my vector of logicals. That vector of logicals will now have true wherever there is data and false where there's missing data. In fact, let me go ahead and run that score logical, and let's look at it. There's quite a bit of data here, so it's going to be pretty long, but there it is. So everywhere you see a false, there's no data. And that's because I use that exclamation point to make falses true and trues false. So now if I use this logical vector inside my subsetting or extracting operator, it will then give me the last names of only those students who have data available. So I'm going to run that. The next one similarly is going to give me the first name and the next one's going to give me the score. And now I'm going to create a new data frame with my new last name, first name, score, and call that student data. That's the name of the original data set, so I'm overwriting that data set. So let me click on that, student data, and let's go ahead now and look at our new student data. And you'll see, as we scroll through, no more NAs. It's a little bit smaller data set because we've removed the data for the students who did not come to the exam. So that's the brute force method, but now let me teach you a new function and use a more elegant, simple method. I'm going to read in the original data. So now I'm back up to having the data here with NA in it. You can see that. And so now I'm going to use a function called NA-omit. And what NA-omit will do is take out the complete row of anyone who has missing data. So there, in that one fell swoop, I'm back from my 48 students to the 46, having eliminated the two students who had missing data. Okay, now that I've done that, I'm ready now to figure the interquartile range. So let's determine if a score is in the interquartile range. I'm going to use the quantile function. This is a statistical function. You should know what a quantile is. This will provide for me the quantile that is the 0.25 quantile, which is the same as being the first quartile. This will give me down here the 0.75. So let's go ahead and get those. We can see down here in the environment, the first quartile is 77.2. The third quartile is 86. Now look what I'm doing. I am going to create a new logical vector called IQR, and that will be based upon this logical or Boolean operation. I'm going to look to see if the score of the student is greater than the first quartile, and remember, and means they both have to be true, and less than the third quartile. So what will that logical give me now? If it is in the interquartile range, it will give me a true. If it's not, it will give me a false. And I'm going to put that in a new IQR variable attached to, look at this, my original data frame. So when I click on this, if I now look at my student data, I now have a new IQR. We see a false when we're outside of the interquartile range and a true when we're inside the interquartile range. Now I'm going to change that from false to true to make it a little more obvious using the if-else. The if-else is another function that we can use with vectors. Here's what it will do. It will look at an element of this first variable we put in, the first object, which I'm putting in that whole vector, the IQR column. And if this value that's here in IQR is true, then it will return this character I put here in IQR. You can put whatever you want here. That's what I'm setting it to return. If it's not true, then this is the else part of if else, then it will return out of IQR. And notice I'm storing that right over top of IQR. So when I run that and now look at my data set, all I have done is everywhere there was a true before, like this third student, there will now be in IQR for interquartile range. Everywhere there was a false, it will now say out of IQR. Now we could have done this all in one step instead of doing this thing up here where I did on line 212 and 216, I could have combined it. Look at this. If, and now here I have my logical statement. That is, if student data score is greater than Q1 and less than Q3, then put in IQR, else out of IQR. In other words, I didn't need to temporarily replace it with true false. I could put it in just the way I want it right from the beginning. In the next step, we want to assign grades. So here I'm going to use a brute force method to assign grades. Then I'll show you an elegant method with a new function. So here's my brute force method. First, I'm going to establish a placeholder for grade. So I'm creating a new variable called grade, and that variable is simply going to be from 1 to however many scores I have. So if we look at my data now, I have 1, 2, 3, 4, 5, 6. That's just a placeholder. And I'm going to replace that here with grade. And I'll show you why I have a placeholder there. I'm now going to use our new function we just learned about, if else. If the student's score is greater than or equal to 90, then let's change this grade, let's change this right here, to an A. Otherwise, let's leave it the way it was. That's why I have that placeholder there, because I need to be able to put something in there if it's not an A. I'm just going to leave it the way it was. Look at the next line. If it's greater than or equal to 80 and if it's less than 90, then it will be a B. And you can see the rest of the way it goes on with this. So if I go ahead and run all these, and then look at my data, I now have grades for each of those students. So I have completed the task. I have the score, I have whether or not they're in the interquartile range, and I have the grade. But let's look at a more elegant way to do it. Again, assigning grades with a function cutoff, we'll start by emptying the vector. So I'm going to go ahead and empty student data because I want you to know that it really is working. So look here, I took the grades out, okay? They're gone. So you know that it actually does work when I use this one command. Look what this one command does. It's the cut function. The cut function will take student's score and it's going to cut it based upon these cut points from 0 to 50. That will be the first cut point. From 50 to 60 will be next. From 60 to 80, from 80 to 90, and then from 92, here's a little R word that you probably not seen before. INF stands for infinity. In other words, then 90 and anything over. Now, what this says is whether you want to use the right hand side of our bin that we're creating, whether you want to use it as part of that bin. In other words, when I go from 0 to 50, do I want to include 50 in that or not? And since I have false, then not. So 50 will be included in the next bin. So 50 to 59 will be my D's because 60 will not be included. So that's what that right means. If you wanted to make 50 included with the 0, then we would put true. And now here are the labels that we're going to use when we create these cuts. So let's go ahead and try it, and let's look again at our data. There you go, did it. And now let's put this all together, and here's how the entire script with perhaps a minimal number of lines could have looked. Let's do it. Read in the data, omit the missing data, calculate the quantiles, put in IQR or out of IQR depending upon what our Boolean operator, our logical operator, decides, and then use the cut function to create grades. Looking at it again, close that data and open the new one. There it is. We could have actually eliminated 2 more lines to make this a 4-line script by doing this. So notice here what I did. So here I'm calculating the quartiles right within my if-else. So is score greater than first quartile? Is score less than third quartile? And that way I don't even have to calculate those quartiles ahead of time. Now, why might this be a bad idea, I ask? Pause the video and think about that a moment. Okay, welcome back. Here's why it might be a bad idea. It might be a bad idea because for every student's score, we have to come down and recalculate the quantile. So when we get the first student's score, we come down, we calculate the quantile, and then we calculate the other quantile, and then make the comparison. And so you go to the second student's score and you do it again. The third student's score, do it again. Whereas before, when I did it up here separately on line 258 and 259, and then we used that on lines 261 through 264, we didn't have to recalculate the quantile each time because we calculated it first and then we plugged it in. Do you see what I'm saying? So if every time you get a score you have to recalculate, you're going to take more time to do it. Now, computers are fast and you might not notice that it takes more time, but it would take a little more time to do it. Except, turns out this is not such a bad idea after all, that you can do that. Why? Because the logical operators in this code are vectorized. And in the next video, I'm going to tell you what that means. We're going to look at vectorized functions.